Good morning. Today I'm going to create a series of instructional videos to support what we've covered in class. So when we're doing motor control, there's a number of different approaches you can take. First and foremost, you need to define your trues and falses, or your conditions. Okay, so typically under a true condition, we're going to state that we indicate a true as a 1. If we're looking at TTL logic, it would be a plus 5 volts. If we're looking at industrial like HVAC systems, that's a plus 24 volts, or a lot of industrial systems. But essentially we can say that an object is energized, or there's an object present. Okay, and then you have your false. So that's indicated by a 0 or 0 volts or 0 volts, de-energized, or no object, right? Okay, so there we have our first set of conditions. Next, we need to understand how our components work. What devices are we going to have? So be familiar with your devices and their device operation. So for example, we have a pressure switch here. Now this pressure switch, we have a pressure switch, and in the laboratory we have this switch here that goes up to 100 psi. But then we come down here and we look, and if we look in the specifications right here, that we actually see that this switch has normally closed or normally open contacts. That means we have the choice to connect that switch in a normally closed position or a normally open position. Okay, and the way that that device is going to work is, say we set it for 30 psi, it's either going to open at 30 psi as we've drawn it here, or it's going to close at 30 psi. So you have to make your decision on how you're going to connect your devices. And so you have to know what your physical devices are, how they operate, how they function. And then you want to define how you're going to connect them. So again, whether we're going to have it in a normally closed or normally open. Okay. Now typically, right now as I've drawn them, they are being drawn in a de-energized state. Now remember, there was at this point in time, if there's no pressure, we're in a false condition. Okay, so we're going to change conditions when we apply pressure up to 30 psi, if that's our setting on that pressure switch. So what I've drawn here is, you always draw in the de-energized state. So when we do energize, that one would open and that one's going to close. So in most cases, a normally open de-energized is going to appear to be false, but when we energize it, you'll say the switch is closed, or true in the fact that we're passing current. Now if we take this to ladder logic, Go a little further here. If I have a switch, and I've drawn this in class a number of times, and I'm connected to some sort of armature, and I have some coil here. Okay? I've drawn a normally open switch, electromechanical relay, and there's 0 volts applied. No current through the coil there. Now I apply a voltage, so a true 5 volts. I'm going to build a magnetic field. That's going to pull the armature down, thus closing the circuit and putting the circuit in a true or energized state. It's for that reason that we consider a set of contacts, normally open contacts, to be true when we start discussing Boolean algebra.